All right. Bienvenue, bonsoir. Everybody stayed. Je m'appelle Mike. Merci Viviane, merci Novencia pour l'invitation. Je parle petit français. Talk with me after. I'll give the rest in English. But thank you everybody for sticking around here with us. I'm going to be talking about large and unfamiliar code bases and how to navigate them. And this is a little bit of a preview of a talk I'm going to give at C++ on C in the next week. Again, encouraging folks to come to conferences, give talks. It's a great experience. So you're going to be one of the first audiences, again, to see this talk. And feel free also to ask as many questions as you like throughout the talk. We'll keep it interactive, and we'll keep it to within our hour limit or so here. I'm primarily a teaching faculty. I'm over at Yale University, and I'm interested in computer graphics. I got to talk with a few of you about this. And some of you saw my talk last year about concurrency. So performance, game engines, these types of things are of interest, where I want to dig down into the system and understand what's working. And that's part of the goal of this talk, just to understand a few of the basic and a few intermediate tools that'll help us with these types of things here. So feel free to ask me anything about that as well. Maybe where we should start, just a question in the audience, and we can take hands here. What's the biggest code base you've ever worked on? That you're allowed to say, lines, number, yeah.
Oh, I don't know exactly the number. Bloomberg.
Bloomberg, okay, so yeah, pretty massive company that's been around for a long time. Safe to say millions of lines of code, probably. Yeah. Other folks?
150 megabytes of source code.
150 megabytes of source code. All right.
Without objects, just source code.
Just source code, not object files. So stacks and stacks of papers if we print them out. Yeah.
Basically full OS.
Pardon?
I work basically on the full OS.
Full OS, yeah. So a lot, yeah.
The code base itself is several gigabytes.
Several gigabytes, wow, of source code, object files. So safe to say, a lot. If you're, working at any company for some time, right, our code bases tend to grow too. I mean, did any of these code bases get smaller over time? Probably not. Yeah. So, yeah, and you find the delete button. So, usually these code bases don't get smaller, right? Unless somebody deletes the Git repo or something. Usually our code bases also don't get less complex over time, and that's often a function of their size, right? As things get bigger, sometimes they get more complex. Not always, but you understand the idea. And oftentimes, again, the code grows faster than we can document it or understand the changes or why stuff changed. And of course, we also have this, did anybody just say when your project got really big to your manager, hey, let's just scrap it, it's too complicated, let's rebuild it? I don't think the business team's going to like that, right? It's sometimes the way that's how we feel, right? We might want to rebuild things, and there's, of course, value in rebuilding software. In fact, that's actually a skill sometimes, to throw stuff away and rebuild it when you learn from your code. But oftentimes, again, our code is growing larger and larger. So again, just for some scale, as far as code bases go, things are in the millions of lines of code. Anything, honestly, once you start getting, an iPhone app could be 40,000 lines of code. That's starting to get pretty large, right? It's large enough that you can't always keep that amount of information in your head. And again, if you look at some of these, and these are older benchmarks, but Meta or a browser, 10 million lines of code easily for those applications. So again, if you take a textbook, pick your favorite here. This is a book that's, 1 million lines of code. It'd be about 18,000 pages of text. So that's 14 of these guys stacked on top of each other.
It's 2 books.
2 books, yeah. And I don't know what 150 megabytes is of code, but that's 100, right? Plus. So again, there's a lot of interesting text and architecture, right, going into software. And oftentimes different types of architectures in different parts of each software that we need to understand. Scale is one of the things that's kind of obvious that makes code hard to understand, but what else? Why do we have this problem? Why can't I just keep all of, a million lines of code in my head? What makes it hard, or what's made it hard for folks in the past?
We're humans. It's 1 million.
We're humans, yeah. Other hands?
Way of coding.
Indirections.
In directions, yep. So where the code's coming from, if you own it. What was it?
Different type of code, different style.
Different style. And this could be just within, right? We work in C++, so C++ 98 and C++ 26 coming soon, right? And everything in between. Other things? Lack of documentation, yeah. Again, read the source code, right? That's what folks say, but that's not great, right? Why is often missing. So no documentation or where to get started.
Coupled architecture.
Pardon?
Coupled architecture.
Coupled architecture, yeah. If I change one part, it's going to change another, but and that might change another part. You may or may not know that information.
Wrong the implementation.
The implementation itself, yeah.
Wrong. Not missing documentation, but.
Oh, wrong documentation. Yes, yeah. Yeah, does our documentation keep up with the actual source code? Yeah, because it could be misleading. And that's why some people say, don't bother to document it. And you say, oh no, what do we do, right? So again, all these reasons, right? The code is just, again, at scale, hard to understand, right? The control flow. How do I go from one branch to another? Okay, this is a simple example, but you scale up even a piece of this type of code, things start to get larger. But as also mentioned, right, you have to also consider where are the entry points? Where's the code coming in from? Okay, most of the time it's a main function, but are we loading code from elsewhere? Where's that coming from? And oftentimes when you're diving into a project, you want to know what the hot spots or important spots are. So how do you just figure out what's important? Okay. State changes, data flow, what things are actually changing matter a lot. Right? We had our lightning talk earlier this evening about const, and that's another thing that kind of helps here. Constant in, constant out. Okay, that's not going to change at runtime. One less thing to think about, right? Might need to know what it computes and some other things, but but again, some advantages of that. And then somebody mentioned, right, wrong documentation, the function's named wrong, these types of things happen. Scale, again, we get the idea. At scale, it's hard to understand things. And then, of course, the human factors, right? Things like your team size or structure. How many folks have heard of Conway's Law? Anybody heard this? There's a few of these software laws that come and go. Does anybody who has heard of it want to?
When you increase the size of the team, and it sort of makes it more complicated, basically. You think it's going to make it easier to write the code, but actually makes it worse. It makes it long. Yeah, it's the idea of if we increase our team, maybe we have a bunch of subdivisions, and all of a sudden our code reflects that, right? Our code has a bunch of subdivisions based off, here's the graphics team, here's the sound team, and then your code is split into graphics and sound, whether or not that makes sense, okay? Maybe it does, maybe it doesn't. But that's sort of, another one of these things that we have to wrestle with that might not have anything to do with the engineering decision itself. So, these other things, documentation as mentioned, no version history, the engineer who knew how it worked leaves the company, etc. All these are human things we want to take a look at. And outsourcing, yeah. There's somebody else who has to plug in some feature and doesn't know about, the culture or the architecture and design something else, right? So all these are very, very human things. So with this in mind, maybe another question before we dive into the meat. Why am I talking about this?
Because you went into the experience previously and you want to make a return of experience.
Did you look at my slides earlier? I mean, that's exactly why, right? I mean, from personal experience, these are the things I wanted to know about. How do I understand code? What to look out for? And I'm going to talk about some tools, many tools that I think you folks have used in some capacity. But I also want this to be for our senior engineers here to say, okay, I've got to pay attention to how we're writing code, structuring, how are we onboarding folks as well? What tools should we give them? How should we document our code and so on? All important things to keep in mind. And also this question, if you're able to make impactful decisions of, okay, is it time to simplify our code base? Let's make that a priority. And some companies, some teams within companies are able to do that, make that business argument of, let's dive in and spend a day understanding the code and fixing it, right? Taking care of technical debt, as we'd call it. Okay, so yeah, it was an honest problem of mine. That's in part why I wrote this talk here, right? Coming into a new job, saying this code is complicated, I don't understand it. I don't want to admit I don't understand it, right? And there's still a lot of code I look at today I don't understand. So I need some tools here to help me, right? To help me at least be able to use some basic tools. So when I do go ask somebody, I can say, I tried this. I tried stepping through the code and figuring out what's going on. Okay, so with that in mind, again, this is also partially my fault as an academic, but I'm trying to fix this. A lot of other faculty are, but we don't really learn these skills in school necessarily. And we have a lot of stuff to learn in school. But reading large code bases, I think, is one of the things, again, I wish I had a class on or had learned some tools going into this. So, I'm trying to fix this in my own courses, but again, these are things we need to think about either in education or within our teams, having lightning talks at your weekly meeting, saying this is what some tool that helps us understand. Okay, and today I'm going to focus mostly on kind of browsing through code, understanding some aspects of it. Understanding code also means things like the performance, right? Again, we had another lightning talk talking about the build system. Why was one tool building faster than the other? That's another aspect we have to understand. There's other, details of memory safety, right? Since we're talking about C++ and security that are also maybe key points. But again, today I just want to focus on what is code logically doing. How do we figure that out when we dive in? All right, so let's understand the code, how it works. Understand how to work at scale so we're not scared when we have, I love this measurement of 150 megabytes of code. Or millions of lines, whatever you like. And then some of the human factors, right? So we can improve. Okay. Now, in order to look at, we should actually look at some code today. And we're going to look at this game called, an unknown open source code base that looks like this. Not Civilization, similar area. Does anybody actually know this game? Oh, I'm going to reveal Transport Tycoon. Yeah, you'll see the trains going here. Civilization, there are open source projects for Civilization or other games. Yeah, free Civ. But this is one, if you haven't heard of this, great. That's even better, right? You can follow along at home afterwards and try to repeat some of these experiments. But it's a nice, charming game about trains taking passengers from one area to the other. Okay, at its simplest form. Trains and cars and planes, just like I took to get here today. Again, if you want to try this, and this is spend 15 minutes after this talk, tomorrow or whenever, download this project or any project. And open source projects are great because oftentimes you have a history, you have various skill levels committing in the code, various people that are hopping in and out of the project. So again, you can really recreate this experiment at home to try out and just understand or look at code that you didn't write, right? How many people have, here's another way to think of this. How many people have written and authored 10 books in their life? Okay. Somebody has. That's awesome. Yeah. Please share with us after. But how many people here have read at least 10 books in their life? All right, so we read a lot more than we write usually. So we should read some more code, okay? That's my point with that. Except for somebody who actually has written 10 books, which is awesome. Okay, so what scale are we looking at to get some value here? And this could be our first tool, clock, C-L-O-C, counting lines of code. That tells us a little bit about a project. So I ran it on Transport Tycoon. And it's a C and C++ project, so there's a mix of code. But there's a mix of legacy C++ and modern C++. And it's about 188,000 lines of C++ code and then another 123,000 in the header. So reasonably large, right? Large enough that I can't keep it all in my head, so it's kind of a good candidate. And there's also a bunch of other programming languages mixed in here, which is also an interesting question of why. Like there's Objective C++ here. So maybe, I don't know, like, is there an iPhone port or something? Maybe, I don't know. But it's already an interesting thing here. D, I love the D language, but that's for make files. That's not D source code. But already some interesting inference, but we see a pretty large project here. All right, so let's work on understanding the control flow a little bit here. So how are we going to do this? Well, the very first thing when you have some project is to actually run it, if you're able to, or that portion of it. Now in a game, it's a nice use case because I can run the game. Some of you are working on, microarchitectures and components that plug into others and make this a little bit harder. But if you can find a way to isolate, the small part that you can run, that's probably the first thing to do. Again, sounds silly and obvious, but it's not always trivial to build projects.
Yeah, it's the second thing, because the first thing is to build it.
Mm-hmm. Yeah.
Time, especially with our projects.
Absolutely, yeah. True story from several projects I've consulted on. I've spent a full week building a project, which sounds embarrassing at some level, but sometimes it is. Okay, you got to download the Android SDK and the iOS thing, all this, and glue it together, and that takes a lot of time. That should probably be the first thing you document to help your engineers. There's usually some mysterious person who knows how to do all the steps, but it's all in their head. So document that. And that's also going to be important that you can build it. Maybe I'm jumping ahead because then you have control over your build, right? Maybe different things that we want to add or remove to our build. Okay, so that can help us understand our program control flow. All right, so let's just start with this though. Let's just start with understanding our control flow a little bit, right? And most of the time where I want to start is the main function, okay? To understand, again, where we start, and at the very least you can see what initialization happens before the project, where do we enter the game or whatever your application is, and what happens after, what the sort of cleanup is. So already, just by finding your main function, you can find some interesting sets of information. Are you loading information from config files? Are you loading shared libraries, maybe? And where do those come from? Are those separate build process, right? So all this interesting stuff just from maybe a few lines of code. And I would say it's probably a good sign if your main does look like this. It's 33 lines of code. I like to keep mine clean. A lot of projects I look at keep them this way, so it's kind of nice. So you can see very clearly what the entry point is. Now, does anybody see anything interesting here in the main? We're going to dive into it immediately, but just from looking at it. Just anything that pops to mind. Somebody mentioned cdecal. Yeah, so there's calling conventions here.
Main, API init, API exit.
Main, API init.
No,
yeah.
Then in main, main, API init, return value, API exit, return 0.
Yeah.
That's all.
Yeah.
4 lines.
4 lines.
You
Yep.
have to go and investigate.
Even better, yeah. A 4-line main. Sometimes people will put try and catch if they want to catch like an exception or something, or run a test. But yeah, even cleaner. We'll hop into this in a little bit here. All right. Well, okay. First off, how do I find main? I'm going to use one of my favorite tools, grep. And we'll try to do this live just to show a few versions of this. So I've got a VM set up with all my tools here. Spoiler alert, another tool that we're going to use here. Here, let's hide that. Let's make it nice and large for you folks. All right, let's find our main here. All right, I'm going to make it large enough so everybody in the back can see. How's that for the folks in the back? Good? Great. All right, so we're in our build file. Let's go back here just to get an idea of the project structure. All right, I've got my source. I'll kind of highlight or point to it here. Let's run grep here, IRN. So I want to do a case insensitive, because maybe main's defined in some way or type def, recursive search, and I want my line numbers. And I'll go for main here. Maybe I'll put a parenthesis here. Let's see here. And I got lots and lots of, okay, so I generated a little bit of data here, but I'll show you the thing here. but my point here is there's all sorts of mains here. OpenGL shader. Okay, so there's some like mains and shaders, which are little graphics programs for drawing graphics. My point of this is, with this experiment is, if we look at the actual mains from the C++ source files, which is our next tool, to go ahead and say, okay, let's just include, let's get rid of all that other stuff, star.cpp files. Okay, that's a little bit better. And let me pipe it out here just so I get a count here. I get 18 results. Sorry, it's in the left corner here in our glare. But there are 18 potential entry points somewhere. Maybe they're test suites, maybe they're shader programs. So we still haven't exactly found our main, but we have a good idea of some places to look at that are entry points in our program. Okay? So grep's an awesome tool, but we're going to want to do better. And I'll show you a few different ways to do better here. Okay, so again, just showing our experiment, right? Grepping around for main is nice, but again, ultimately, remember I said we want to run our program and just see where main is, so we got to get to that. And there's different tools you can use, right? A few of those mains you'll find in binary files, so you can get rid of those. But I end up with about 7 entry points, and if you look at it, you'll find a main. Now again, interestingly, there is the main that we're used to doing, int main, but there is open transport tycoon underscore main, which is the actual entry point of the program in the game. Okay, it just forwards the arguments into that, but again, you'll see that sort of pattern. That's where you actually want to probably set your first breakpoint if you're diving into the game. Everything's been initialized, and then you're actually running in the graphics program. All right, makes sense? Just a little warm up there. All right. All right, now, again, this idea of running our game is important, but we want control over the build of our run of the game so we can add debugging symbols. Super important if we're going to understand what our program's doing. Right? Most of us, this is one thing I think most of us do in school at some point. You add -G to your build, or figure out in CMake, right, where to add flags or whatever your build system is, so you can get more debug information. So super, super important tip. And again, I think we're familiar with this, adding -G. But there are some more write-ups here from the folks at Red Hat and Undo about what if, again, you're in one of those live systems and need to add debugging information or debugging symbols while the program's running. Okay, so there's a little bit more there on the advanced side where you can literally load and unload, right, debugging symbols into your debugger. Okay, so if you don't have them, you can still, and your system's running 24/7, right? You can't turn down a system that's, I don't know, a search engine or something, right? You don't want to say, hey, we're turning things down. You can patch in the symbols in your test environment or whatever. All right, anyways, we need our debug symbols and to do a debug build. So I've already done some debug builds for the little experiments that you'll see here. But again, super useful for telling us exactly where something's happening in the source code that we own. And potentially if we don't own that source code, like a shared library or something, you could, if it's open source, compile that shared library, that code that you don't own, load in the debug symbols if you need to. Okay, a question, yeah?
About finding the main entry point of the program, you could potentially place a breakpoint on the main.
Yep.
And run GDB and find your main entry point of your program.
Yeah. Let's do it. Yeah, why not? All right, so let's take a look. Let's go back into our project here. Like you said, we didn't like doing all that work here, so let's actually just run GDB, as mentioned, with Open Transport Tycoon. Let's make this just a little bit bigger for you folks. All right, so we're running. We're reading in the debugging symbols, or whatever symbols we have. I'm going to use, well, actually, before I dive too far ahead in this, how many folks have used GDB? Okay, this is a good audience. I mean, the folks are going to show up to the meetup. I mean, how many, yeah, a long time ago. How many folks are using, let me do a little more specific. How many folks are using GDB in the terminal, like I'm doing right now, as your primary debugging? Yeah, okay, so half. How many folks are using in their IDE, VS that counts like VS Code, text editor, or Vim or something. Have some integration. Okay. Are folks using Visual Studio? Using the debugger there? Some folks are on Windows. Yeah. LLDB folks? Just kind of curious. Okay, so a mix if maybe you're doing multiple platforms. I'm curious about that. Okay. All right. Well, let's look at GDB. Next question. How many folks are using the text user interface with GDB? So they can actually see the source code. Not as many hands, but still a good number here. Yeah. Yeah. I love this. This is what made me, deal with GDB, I guess. As long as, if we write stuff, I'm going to keep doing Control L. Now, I'm actually going to talk about one of the important parts of, actually, I'm not going to show it here, but attaching to a process and then, piping the output to different windows, a good tool to also have. But yeah, let's do exactly what was mentioned. Let's put a breakpoint on main. Yes, start does, yeah. Yeah, we could do that. So start, we'll put a temporary breakpoint right on main. Right? Let's see here. I have to download some debug information here. I don't know. Let's see if it does it here. Let's see here. Let's see, did it go? Start. Well, let's see. Control X, O. If I scroll up, look, I am in my main. Right here. Okay, so we found our entry point and we can step through it. Right? So essential tool here for us. And let's just walk through it. Okay, so we read in some parameters, do some work there. Okay, we set up some signal handlers. And then, again, as mentioned, we want to step into our Open Transport Tycoon. And then it's doing some other interesting stuff here. Okay, so if I kind of just keep stepping through this, I mean, this is one way to get a good idea of the execution here. So let's just keep hitting, I'm going to keep hitting Enter, which is the same as doing N or Next, repeating my command. And eventually, okay, we got to download something else. We'll get our window here. Question here.
That question, Mark, I usually do something slightly differently. Is starting from the start usually is a little bit boring, and it's lots of boilerplate, and usually it's not where you need to do some changes. And when I discover a code base, what I try to do is more to start from the middle. So, for example, I don't know anything about the code, but there must be somewhere a class named vehicle or train, and I would grab for this stuff randomly, and then put breakpoints inside of it, and start debugging from the middle, because this is where the interesting part has a higher probability of being.
Yeah, right. So you're saying that, the interesting part's probably what's happening with the train, or eventually we're going to dive into like, you're assigned as a programmer, hey, there's a bug on this train, or add this new feature to some specific train. Hold on to that thought for a moment, because that's exactly where we want to go, right? This is, getting us running, maybe digging around the architecture, right? And I can hit, I don't know, let's start a new game here. And then eventually I can hit in GDB Control C. And again, this is where I got to do my refresh here. Control L. No source code. I don't own C++, my GCC span. I guess I don't have debug information. But I can do finish and kind of jump around the stack frame a little bit until I get into some code that looks more familiar. Okay, I'm still in my user library. Finish. Let's see. Okay, now I'm at least in Open Transport Tycoon code and can kind of jump around here. Okay. Now the point of doing this stepping around experiment in any code base, then we'll talk about like actually solving our problem, is to get an idea of the architecture here. So I'm just going to do next a few more times until I maybe see something interesting, like, well, right here. While we're not exiting the game, loop once, repeat forever and ever and ever. That function's probably interesting. There's probably something interesting in there. So, I mean, what we're doing at a high level here is capturing some notes mentally right now during this debugging session. Then we're going to actually want to capture those. To see if there's something interesting in this architecture. What goes into looping once here? Okay, well, we got some, where are we here? We're in atomics. Okay, so there's some, I don't know, maybe there's a loop counter going on in there. Here, let me step into there. Okay, here's our loop once function. It looks like there's a different setup for mscriptin, so web build. Okay, there's a this tick. Okay, games work on a tick or a counter like a clock, right, over time. Okay, that's for the JavaScript part again. and then we keep going here. Okay, so there's probably something interesting we can step into here. Right, and if we keep stepping in here, we're going to find out that every tick there are events being pumped into the system about what train should move or so on. Right, so we get an idea of this event-based system. Why is it like that? Well, maybe some hints of JavaScript, sort of this event-based callback framework engine. So maybe we're trying to work with that in events work. Maybe events just work well in games. So we're starting to get some, again, idea of the high-level architecture here. Okay, makes sense? Even though we might not have, not everybody here might be a programmer for games, we get some idea. Okay, let's end this experiment here and continue our notes. Okay, so what we've done and highlight is this sort of step-by-step debugging from the beginning using GDB on our machine or remoting into some other machine to do something interesting. And GDB is a great first start. In these slides, which I'm going to post, just Google my name, Mike Shah, professor or something like that, and you'll find these slides on my website sometime later tonight. And there's a video recapturing that in 1 minute. Okay, but let's look at more. Let me actually do one more essential thing, because this is sort of the essential thing with every tool that we're using. This time, I just want to show this. Let's just run Open Transport Tycoon. Just another essential skill for our folks to know about. Let's start our game. And again, kind of drilling into this feature as the remark was of, let's do something interesting. I don't know, I'm going to, and I played this game when I was like 5 or 6 years old, so I still remember all this stuff. But, build some train track here. And again, maybe something interesting happened there. So basically what I'm doing here in my terminal is, again, I'm just going to grep for this process and attach the bugger while this is running midway, right? And this is how a lot of you are going to debug or profile these types of things, right? So I get the process ID 3461, and I attach the debugger to it, 3461. Okay, and if I bring this up here, it's going to say, hey, you're not allowed to do that. I'm going to say, okay, I need to be a super user. Behind the scenes, this is using, ptrace or some sort of low-level function here. Okay, now trust me, and I can do Control-C break, and again, that same experiment of finishing our frame here until I get into some code that we recognize. Right? Makes sense? So oftentimes, more often than that, we're going to do that. That's especially helpful, or at least an insight into maybe how you might design an architecture if the game crashed, not to just terminate it. Have some sort of, if you have exceptions, that can be a great way that you can at least jump into your program and try to attach a debugger and recover something. So just a note there, right? Rather than just crashing. All right, but something even better, step-by-step debugging. And again, here's your cheat sheet, which, again, this audience A++ for knowing GDB and your debugger, or whatever, just using a debugger is great. But at some point, you are going to observe something interesting that happens in your program. You're going to try to recreate it, and you're going to miss it. And you're just going to go through and do next, 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 and go one step too far, or the crash won't happen, and that's going to be a problem. So we can push this one step further, and this is also great for program understanding with reverse debugging. Right? So isn't it nice if I do next, next, next too many times, and then I can just go reverse next? Okay. How many folks know about this feature in GDB? That you can go backwards. Okay. Yeah, it's 6 or so. So not everybody who is using GDB, right? A fraction. So yes, okay. Everybody has to learn at least one new thing here. And for the 6 who raise their hand, I got to figure out something for you. Right? So let's play the reverse card here. And you can do your reverse debug with GDB. Okay, so again, very useful for your code exploration. You can basically just do reverse next. I, in particular, I'm going to show you a few demos. I use UDB, Undo's time travel debugger, because it's faster. And the snapshots are smaller. So, that's just a word on what that is. Have folks heard of UDB? Thanks for folks, not as many. Have folks heard of RR? There's another time travel debugger. Yeah, that's also available on Linux, so you can time travel with that. So you can check either of those out for time travel. But I want to show you a few cool examples, and you can try it out from the slides. We do have Tony from Undo, who's here, if you do want to talk to him about UDB and debugging, which I recommend. And I recommend, again, trying it out on the Transport Tycoon. So anyways, let's get to this. So the cool thing about time travel, whether you're doing it in RR, UDB, or GDB, is you can capture some sort of snapshot, which again is going to be useful for showing to somebody else, or those troublesome bugs, let's say, or that one time that you happen to be playing the game and something weird happened, right? And you want to sort of capture it. You can basically replay the recording by doing next, next, next through the recording, or reverse next. Okay, so just to show the basic functionality, let's see if this will play here. I might have to connect here on my internet. I'm on somebody's network. I don't know. Here, let's see. Oh, there we go. All right, so I have two examples, and we want high quality here. So what you're going to see is this is not running Transport Tycoon. This is just running a replay of the actual step-by-step debugging. So I'll show you this twice. Once with just a basic. If you haven't seen this, I'll narrate what's going on. Okay, source code layout. I'm sorry if the font's a little bit small. Basically, I'm at my breakpoint at 467, and I say I want to go backwards from here, reverse continue. So same thing as continue, but instead of going forward, I'm going to go back up the call stack. Okay. I mean, and that's as simple as that, right? And I can actually see this state changes. So that's really helpful if you have recorded and seen something that has happened. Again, you can use GDB, UDB, pick whatever tool you want. And again, you can go forward and backwards. Just keep an eye on where the cursor is. Reverse next or next. If you play around with that, that's an awesome skill to have. But let's push it just a little bit further here. Oh, let me advance the slide here. And let's see here. This is, so for those of you who are coming to C++ on C, my other a friend, Chris, who works at Undo, he captured this one here, which is a little bit more interesting because it's got the graphics here and is solving a problem. And now we're saying, I'm going to let this, or just highlight this. I've got this train that's running here, and I want to know something about it. Maybe there's a bug, right? And again, it's delivering its passengers, or in this case, coal, to the station, and you're going to make some money. Okay. Now, what's interesting about this? Let me see if I can run it here. I'm going to dive straight in the code. Sorry. Let me just kind of narrate it, and then we can take a look. There we go. Let's play this one in full screen. Anywhere you have a state change in your code, right? So a train delivers passengers, coal, right? Some value's changing. So instead of just having to guess and put breakpoints on something, what we actually want to do is look through, and this is, a sort of dump of a train structure. So somewhere here, I did p-type train. I looked for some type in a field in it, and just put a watch point on a field of a train. And the field, basically what it does is it keeps track of how much money that train made. So as I deliver passengers or coal to some place, a value changes. Make sense? So just with a watch point. So in between that value changing or not changing, the point is if I put a watch point on that, I can go forward and backward in between 2 points in time easily. Does that make sense? So that's how you can use time travel debugging better than just guessing, oh, something interesting happened here. Right? You want to actually see where something changed, some interesting state change. Okay, so again, here's our train. Let's see. Let's let it run here. All right, so we eventually hit a watch point. Sorry, it's small font. We'll have to, I'll increase this later, but two values changed, okay? And now I can reverse continue back and forth between the two of them and diagnose any bug. Make sense? It's kind of cool stuff. Are folks using watch points? All right, awesome. All right, we got a good crowd here. Yeah, but are you using watch points with forward and backwards? I don't know. Anyway, so there's all sorts of interesting stuff you can do here. Now, okay, we just did all that interesting investigation, back to the understanding of the code. Did you take any notes about what you learned? If you're like me, no. I just said, I figured it out. I'll just figure it out again. I'll hop into GDB every day for the rest of my life, or whatever tool you want. Keep a code journal, right? Keep it written if you have to. Whatever your company's internal document policy is, you should write something. John Carmack was famous for writing these .plan files, which were basically to-do lists about what he was working on in a public directory of his findings. I just keep a Google Doc. And most of the companies that I've worked at, I keep a physical thing because I can't upload stuff on the cloud. But anyways, that's just my pro tip here. Okay. Now, how else can we find what was important? We've got sort of this idea to hone in on maybe systems that are interesting. Like if I click a button, okay, with watch points to go back and forth, or I want to know something about a train as values are changing. But oftentimes I want to do something like performance. Okay, a lot of us are working in performance as talking to something's too fast or too slow. So we have to use profilers. Again, let's just do it for completeness sake. How many folks have used a profiler here? Great audience, most of the hands are going up. If you haven't, no problem, but it's something that can be quite useful. But basically, getting a report of where your hotspots are, meaning where you're executing code a lot or a little, is interesting. So again, perf is an example profiler. Most of your IDEs probably have something integrated. So I'll spare us this part and instead show us something that might be new. Visualizing these reports here. So let's actually do it. Let's take a look. I'll log back in here. And this particular tool is Linux specific, but there are equivalents for most of these. Let's see here. Let me just close this down. And this one is as simple as, I got a lot of stuff running here. Yeah, we'll quit that. This tool is called Kcache Grin, like you're smiling, or grind, people will say a lot. But what am I looking at here? Okay, a whole bunch of boxes. But this is another visualization of, through an execution of a program, collecting some samples of what function was executing. Okay, so this is the bottommost layer, and then a bunch of boxes stacked on it are the call stack. The bigger the box, the more time I spent there. A little bit more intuitive. And sometimes it organizes and gives structure. But what I really like is if I click on one of these functions here, and let's sort of, we could look through our list here, right? We learned what the main function was, or maybe something interesting. If I click on one of these, I can get a visualization of it, okay? Which is, probably the most interesting part here. All right, so I can scroll through it, see how much time I spend in the hot and cold paths. This is interesting from a programming understanding point, maybe just for my journal, for myself, maybe if I'm explaining this to a colleague, or maybe if I'm doing other types of optimizations in my code, profile guided stuff, or again, there's many use cases for this, of figuring out, how did I get to one path or not, right? What important systems were set up, okay? So visualization's a nice tool here. Has anybody used Kcache Grind? Or a few folks as well. Are folks using other visualization tools? Anything? Yeah.
Is the Intel one?
Intel's vTune, or yeah, yep.
I think you can import your perf profile into Firefox.
In Firefox, yep, yeah, because Firefox is I forget what the name is, but they have that available.
Insights was the greatest one I used.
What Insights?
Unreal Insights.
Unreal Insights, yeah. Okay, for game programming, or yeah, awesome. Yeah, and there's other tools like flame graphs and these types of things that you might have seen. Brendan Gregory did a bunch of nice profiling work, and I think wrote some books on this. But that's just another thing I'll throw out there. So anyways, this suite of tools, this is part of Valgrind, which is a memory profiler, which is a suite of tools. Callgrin is monitoring those tools, so again, useful for code understanding. Okay, so we saw the visualization here. Very nice. Okay, so again, you can kind of work your way through what we call the call tree or call graph of what actually happened during an execution. Okay, and oftentimes combining these tools with the same stuff that we learned about before is, how you get your full understanding. Okay. And you have source views and these types of things in these tools, which is nice. Okay, so, that gives us a pretty good understanding. Like, if I had learned a handful of those tools before, my first job, that would have eased my concerns, I guess, or given me a few, things that I could always try. And again, these are pretty simple tools to learn overall, but they also scale quite well, okay? Because there's another part to that, time travel debugging or GDB step through of, okay, I'm stepping through to understand the control flow, but I can query other things like how many threads we're executing or other interesting information once you have a general idea of the architecture. Let's talk a few things about scale. Right? We looked at this code base, 300,000 lines of code, or at least that was the size here. So really, the only way to deal with scale is to reduce the size of, the problem we care about. That's why we use abstraction and are sort of taught this lesson in code, right? So we can manage complexity. Okay, so text is our visualization most of the time. Here's a silly suggestion. Get a large monitor. Yeah, you came all that way to hear this, but you'd be surprised how often, beg, borrow, or, acquire a monitor because you're reading code. That's your visualization, right? And you're going to have all these tools. Some of you are working remote. So again, that's helpful. There's other tips and tools on screen management. The number of times that I've need to side-by-side look at code, whether it was a git diff, which is the most common, or just two similar codes or algorithms is so often, again, thinking about something that helps you split windows and manage them well is a good idea. I use Vim because that's like the maximum real estate I can get. But the other thing I think I like doing is, for the folks who didn't have documented code, is just generate it yourself. So there's nothing illegal as far as I know. But again, your company may vary, about just running Doxygen, DoxyPress, or some code generation tool on your code base, right? And again, it's as simple as usually Doxygen-G. It'll take most of your C++ style formats, even if you don't, you have to specialize them, right, with like 3 slashes and there's these things. But even if you don't do that, you'll still get a high-level overview of the code, okay? And maybe if you get no comments on some code, that's another thing you can sell to your boss and say, hey, we should look at this code and see if it doesn't have comments because we don't understand it, or whatever is going on here. So anyways, the short of it, I'm going to skip through this video here a little bit, is generate your Doxygen for your project. There's a little bit of configuration you can do to make the documentation pretty. But again, this is a 1-minute video, so you can do this in 1 minute. All right, so it's going to generate. And then I'm going to bring in the window. There's our Transport Tycoon documentation. And then we wanted to learn about trains or whatever. Click on classes at the top and then go through and find all of your classes. And oftentimes too, why I also like this is it saves me from a lot of embarrassment, meaning, right, when I have the documentation in front of me, I have stuff like the inheritance hierarchy, which gives me some idea about the architecture, if I should inherit from something, what types of things I'm doing. And also just a little bit about naming conventions. Okay, are we returning fixed width type things? Is that the style? So when I go into code review, I don't totally mess this up and use the non-conventional thing, right? So I kind of look smart. So that's just kind of a nice thing here. So again, for your notes, returning string IDs. Do I return pointers to things? Do I return handles to things? You can kind of get an idea of what that is and ask the question, why would I do that to the internet or ChatGPT or whatever? Okay, a few other things on scale. So figuring out sometimes the code you don't own and either don't have to care about or maybe need to investigate is important. So I was talking with some folks about shared libraries earlier. LDD, seeing what libraries you're actually loading and your dependencies can be important to kind of split and fragment out that project. To again, see about what you can or can't control. If you're on Windows, Dependency Walker, again, there's all these tools that you can, for each operating system you can look at. And I also like offline documentation. I use ZealDocs, DashDocs is another one, where you can generate it for your code base or those APIs that are common but you don't own and want a quick reference. You'll save yourself a lot of time looking through offline documentation. Or at least I do, right? A web query costs me time. So I like to just look it up. All right. Still too much stuff in Scale. Tests. We have tests. Hopefully your code base has tests. Again, maybe something that you could reasonably argue for. But again, oftentimes small snippets of, maybe they're unit tests to give you an idea about a specific function, or the integration test or behavioral tests, right, you can look at. Again, common wisdom maybe, but if you have some tests, take a look. Also great things to step debug through, right, if you don't want to go through the whole project. I think this is just a forward-looking thing. There's a whole world of software visualization waiting to happen. This is something called Code Cities. I was interested in this as a PhD student, but it's a metaphor of this is your code base. A block is, namespace or maybe a file or something. I think we're going to need some of this stuff with all the AI-generated code to help us, right, understand what is going on. Maybe for the coders, maybe for the non-coders, but I think there's a world where this stuff is needed. So that's just looking a little bit forward. Some other general tips on Scale, studying your design patterns. Yeah, they don't fix everything, but again, you'll notice things that show up like event systems or observer patterns or these words like subscribe, that means something, okay? And you can kind of get an idea or code up a little system yourself. Just whatever the smallest, tiniest sandbox example is, and try to learn these things, okay? There's a great book also, The Art of Open Source Architecture, that's got, there's several editions of it, but there's at least 20 or 30 projects, and I'm willing to bet there's at least one project that might be similar to yours that shows how to put those patterns into practice and solve a problem. So again, looking at other code, often helpful. And then text editors, of course, are getting better at showing us stuff here. So this is just about inference. I was just playing around with C-Lines tools recently, and it has its whole AI thing built in that'll tell you kind of what's going on. And so again, maybe there's more stuff there. All right, last section and last few minutes. Human factors. Yeah, Vivian.
One of the tools I discovered a few years ago is called codebases.
CodeMap.
Yeah, it's a tool that tracks your Git or VM history.
Yep.
And create heat maps of what changed, and
Yeah.
also is often able to display coupled stuff. Because
Yeah.
on one commit you change this one and this one dozen of times.
Mhm.
So there is it shows dependencies that were not visible in the code.
Yeah, awesome. So CodeMap, I'll just repeat for the Discord folks, that shows the diffs or over time how your Git history has evolved, and you can kind of see as a heat map what has changed or not. Yeah, awesome. You can kind of see what folks are working on at different times to see what's important too. That's a great way if you're a new engineer on a project. Yeah, other comments or questions?
Before we go to the next section, regarding the LDD
Mhm.
and the dynamic libraries,
Yep.
sometimes they're loaded dynamically.
Yeah.
And you don't get to see them in LDD, and in
Yeah.
that case, you have LD debug that can help you, but it's
Yeah.
very, very verbose.
Yeah. So you can look for LD debug to maybe see, okay, yeah, what paths am I looking for? And then I guess, your other option is to look at, okay, if I'm on Linux, look for DLSym or whatever that function is that loads symbols dynamically, or find some, make some log of that. Yeah, so it gets more complicated than, this. Yeah, awesome. Yeah, share your tricks. I need them. Other comments or questions on Scale or other tools that folks have used? Yeah, here and there.
Just regarding the time travel functionality for debuggers, does this functionality ensure consistent states on CPU registers and hardware counters and stuff like that. I mean, when you go backwards.
When you're going backwards, yeah. So my understanding with those tools is it's capturing the actual state, right? All the system calls and the reads and writes that have happened. So it should be consistent as far as playing forwards and backwards. Like I don't think there's anything changing or risk of changing. And well, I guess, I mean, is the question about something like, okay, if a file handle or something outside is changing, or I thought, yeah, maybe after.
I just wanted to know if the machine overall is in the same state it was previously when the instruction was executed previously.
Oh, I see. Like if I mean, the machine itself might have like other programs or noise in the background. So, I mean, that could be that's going to be different, I guess. Yeah, but
we just try to understand. Imagine you have 4 lines of code. On second, you have changed the value, and after that, on third, you crash. Maybe.
Yep.
You go to back before you change the value. So actually, changing the value makes you crash. You have to step before.
Yep.
If the state with undo, go to the value before the changes, or still with changes.
I see. So my understanding, Tony, correct me if I'm wrong. If I'm going back, it is recreating the state before the crash. Yeah. So I'm able to basically replay that crash over and over again, right, and see what was triggered. Yeah.
What we're doing is we're evaluating what your system calls are, what your asynchronous IOs are at the time that you're running software. So that's recorded, and then we take a snapshot, and then we replay all that non-deterministic information to recreate the state. So it's always faithfully reproduced.
Okay.
Yeah, so it's an awesome tool, and using it on games or these other things and capturing these snapshots is, I don't know, it's super fun to try playing around with it. Yeah, it'll get you hooked. Yeah.
You didn't mention the tools that allows to extract the architecture of the software from the source code. I know none of them which are perfect, but some they can be helpful. You showed Oxygen, but the architecture which is shown by the Oxygen is very poor, I would say. It's mostly class inheritance, which is better than nothing, but it's not helping a lot. But you have other tools that allows you to get the full architecture and the dependencies between classes and everything. And usually when you try them the first time, you are overwhelmed by graphs with thousands of, but the quality of implementation of those tools is if they provide you ways to group stuff together, to filter out stuff, to zoom on a small part and it can allow you to discover the structure of your code better.
Yeah. So there are a few tools. And again, the comment is, at scale, right? For instance, if I run Kcache grind and put together all those call graphs, I'm going to end up with this massive tree. So I do want some way to either, and there are some tools. I should put it here, but basically you can collapse kind of the connected components and have just a few nodes to look at and expand them.
If you just collapse them by file or by folder, it's already giving you a high-level view of your architecture.
Yeah.
Even because Oxygens give a lot of information which don't need it actually.
Yeah.
Model.
Yeah. So don't necessarily need all. I mean, so maybe it's too much, or again, collapsing that information is
I tried to make it a Oxygen of example I don't. It's impossible to understand. At the beginning.
Yeah.
After that, you can minimize, but not from the beginning.
Yeah.
It's impossible.
I started with like LLVM and their views and like doing the Oxygen of that, and it's a massive thing, exactly as you said. So finding some way to scale it or one small part, starting with a class. I actually ended up building some visualization tools on top to collapse the nodes by namespace or subsystem. Sometimes you can actually annotate. I mean, you'd annotate in your code the same way in a profiler, you might just annotate with a pound define, profile here, start here or stop here, and get like a small piece. So yeah, great suggestions on dealing with scale. Yeah.
Sometimes just limiting the number of levels of your graph help a lot, because most of the time you don't care about the full hierarchy for a function or a class or something. You just care about the next maybe 2 layers, and you have to understand where things are going. So usually I only limit to 1 layer, and then I increase if I don't have enough information, just to be able to have some nicer stuff generated.
Okay.
Yeah, awesome. All right, let me take a look at human factors. Just a few things here, right? So, understand our control flow, our scale. The best way to, learn a code base again is to, in my mind, kind of motivate yourself to look at a real problem. Again, going back to earlier remark, like let's actually look at a train and figure out how do I make that train go twice as fast, right? Maybe if you're just like hacking around, or add a new button or a new item to some drop down, right? Give yourself some task that, again, focuses on like what parts I care about, which I think is exactly what this discussion is about. Like, okay, in the Doxygen, I really just care about hitting classes and menu widgets because I'm trying to add like one item. And then you can figure out, is that in the code? Does it come from a config file, etc., and figure out where to trace. Yep.
Since we're about human factors, I think we forgot one very good way to learn the code base is if you have access to a guy who knows the code base, just talk with him.
Yeah, absolutely.
It sounds silly, but it's very, very helpful.
Number one tip, I don't know if I have that, but I am going to steal that if I don't. Every time that I was working somewhere, I would ask somebody, and I would always treat them. I'd say, okay, I'll treat you to coffee or whatever, but let me just look over your shoulder for 15 minutes and guarantee you I'd learned one new like terminal tool or workflow thing or something about the code base. Yeah, absolutely. Talk to humans. We're still here, right? The AI isn't writing all the code yet. Talking to people. I mean, maybe that's a great way to summarize a talk itself. If you're trying to find a good first task, diving into GitHub, maybe, and in this particular project, there are things labeled small tasks, minor details. There was one that is like trivial things to actually work on, can be super, super helpful. And again, these are more things for you as a senior engineer to think about, like, okay, let's prepare somebody new on our team for success. And again, if you don't have that nice, clean code base, you can usually grep for to-do, fix me. I've seen folks grep for swear words before and then, say, okay, or I don't know, like these types of things that go in the comments. Yeah, or later, yeah. I owe you, yeah. So these types of things, right? So anyways, those could be a few things to do. All right, so, more ideas on things I said about first tasks, fixing warnings, finding some basic tasks here, trying to track what some function does in GDB, UDB when you click on something, and journal it for somebody else, right? Writing a wiki page. Those are all things. And whew, I do have this slide, okay. Ask somebody, right? So always be nice to your teammates, right? Always be nice to people you meet at meetups. You might be their teammates later. That's probably the best thing you can do if you're a junior engineer, or even as a senior engineer, to show it's okay to say, I don't know everything. Maybe the junior engineer is the expert on some system, so you can ask them. Try not to put your junior engineers in uncomfortable positions. Sit down with them when they first join a team, walk them through something, and then, take your own notes and say, oh yeah, gosh, we don't have any documentation on that. Let's generate the Doxygen or use whatever tool that we need. And of course, you can screen record like we're doing. Bonus round on AI in the last minute or two here. So part of this I've alluded to, I'm exploring tools that are showing up, right, in our IDEs, on search engines, etc. Does AI solve all this problem of let's feed everything in and it'll just give me a perfect summary of our code? Not quite yet, right? We do need to learn these tools, debuggers, and so on to step through code. if you do have enterprise AI tools where it's safe to paste in some code and try to figure out what's going on, again, maybe that's something you can, do, right? Again, respect whatever your safety policy is, but keep an eye on these things. There are tools like SourceGraph, ChatDBG. I think they're going to improve. They're going to be here somewhere. Yeah.
I'm pretty sure there is some small models that you can train on gated repository.
Mm-hmm.
I think it's available for any public repository.
Mm-hmm.
You can paste the URL and it will answer maybe accurate with a known accuracy, but you can try it.
Yeah. So yeah, nice comment about it. There are some models where you could take your code base and train it on, or try with like this open source one and see how well it does. Does it match your findings, right? Maybe it's a good confidence indicator of some sort. Yeah. Okay, so more resources. This isn't the first talk on debugging, debuggers, tools, time travel, visualization. I've listed a bunch here, which again are probably best taken. You can grab a picture of the slide if you want, or just grab the slides online. So in summary, right, we've learned about understanding control flow, some different tools, how to walk through, right? You've heard from some experts here, how to wrestle with the scale of software, right? And shrink it down. And again, not to forget, we're humans and how to sort of motivate ourselves or talk to each other. And with that, thank you. Yeah, I see. So I'm happy to stick around for other comments, questions. I don't know how long we have the space, so thank you again, Novencia. Great, yeah. So yeah.
I was asking because it's a lot to learn about compiled languages such as C++.
Mm-hmm.
But if you need to read to understand large code bases in scripted languages, do you have some tools or tips to give that are different than compiled languages?
That's a great question. So, I mean, even in this web browser, right, I can go into the debugger. So for things like JavaScript that are very, dynamically typed and these types of things, I think a lot of the advice still applies, meaning like running debuggers, visualization tools, looking at Git logs and these types of things to understand what's going on in the code. In some ways, you have an advantage and a disadvantage in the scripting language. There's the advantages of being able to often query a lot of properties at real time. But again, the disadvantage of, you don't have a type system to fall back on for things like correctness. But I guess I'm trying to think, a lot of the same advice applies. I'm trying to think if there's anything extremely different. I work in C++ most of the time, so that's part of the problem. I don't know, has anybody found a great tool for JavaScript or is doing Python that they really love that's helped them? Yeah.
Just something I saw that not everybody know why doing Python. It's since Python 3.5, I think.
Mm-hmm.
You have the function breakpoint that open a PDB when it's hit by your Python interpreter. I think it's the same thing will be available with C++ 26.
Yeah, I think we're getting like a stack trace object.
Yeah. Debug, and if you're running with GDB, your C++ code, it open the debugger.
Awesome, yeah.
And it exists in Python, so if you do some Python and some really, really complex and strange kind of Pythonic way, you can just type.
Yeah.
Can you repeat the name? Breakpoint. The function. It's a function. Okay. It's a special built-in.
Follow on there.
Yeah, I'm thinking that maybe one difference is that with statically typed languages, you have tools that can extract the architecture and visualize it for you. When everything is more dynamic, you cannot just look at the source code to get the actual architecture, because the actual architecture is something that happens while you run the code.
Yeah.
So tools may be lacking in this domain for dynamic languages.
Yeah. Yeah. So.
For Python specifically, I find that Jupyter notebooks are really helpful. Like more if you're using a library that you don't know, rather than existing code. But it's Jupyter notebooks. I think it's a really good tool.
Yeah, I'm trying to think if we have I mean, in C++, we have the equivalent of going into Godbolt and writing like a small snippet and sharing that. But yeah, maybe we need something more of a Jupyter notebook, or
You can instantiate, or you can use C++ in Jupyter notebooks. A little bit tricky to get going, but you can actually do it.
Cool. So each note is basically an instance of the compiler running or something. Yeah.
I've got it going a couple of times, and then I've left it for a while, and it didn't work now after a while.
Yeah. Great hints. Yeah.
I know that you can, if you need to debug a Python script that's running, you can attach a GDB to it, and there is you can import a bunch of stuff that's coming from GDB to have the correct stack frames as if it was PDB.
Oh, okay, cool. Yeah. Yeah, because there's a whole, I mean, even within GDB, so you can, execute the Python code. GDB has its own Python API, so you can write interesting scripts. There's probably another part of this story, that I think about a lot too, especially in the gaming world where I come from, where C++ is talking to Python and scripting, so across language boundaries, code understanding. Some of that just has to do with like instrumentation of the libraries itself, so that those are other ways just to get more information out. But yeah, I'm trying to think. I mean, it's quite often too, I'll output like a dot file, which is the graph representation, right? The edges that you get of my code flow or some important information. So that's another thing you could do in both, but you might have to construct it yourself. Yeah. Other questions or tools or that folks are using that have been really helpful, or that we really need? And you're like, if I had this would save me time.
One tool that's really helpful is UML graphs in Doxygen. That's if especially if there's not a lot of people working on a project, just rather than the full paragraph, just a UML showing what's happening. Key functions.
And in your experience, has it been, working on a team that you're building the interface, and that's been very useful to kind of sketch it out together and figure out what the API is, or?
Yeah, it's more like, for example, a sequence graph to figure out what network protocols actually happen when you use this function.
Yeah.
So, and that helps me to understand the code.
Awesome. So sequence diagrams and UML. Yeah. So yeah.
Quick thing. I don't know if anyone has had the same problem, but whenever I try to use watch points in my code base in my company, I cannot do. I think there's a problem with permission. I don't know the exact technical problem. Why? I don't know. Is it only me?
I know about watch points, but we have an issue with corporate spyware called Titanium that breaks that inserts interrupts inside some Cisco. So if your software opens a socket, you can't use Valgrind because Valgrind will catch the
Interesting.
And break.
Interesting.
The issue has been raised, and Titanium says, "Well, whatever." Who needs a debugger anyway?
Interesting. Interesting.
Who needs this component to the cyber?
Well, I know that management says otherwise. So.
Yeah.
I also find that from experience, many times when working on like huge code bases, I ended up having to write my own tools to understand what's going on. So it's visualizing like a 3D data or two-dimensional graph data or things like that. I think that's a really big part. You end up writing your own like tailor-made tools to understand that.
Yeah, and then those tools tend to live a long time with the code base.
I mean, sometimes you have the chance to share it with like some other like fellow students if you're, for example, still doing your studies or co-workers. Eventually, it becomes stable, I guess. It's part of the code base.
Yeah, very cool. I'm just kind of curious, maybe anybody has any comments. Has anybody gone through a major restructure of a large code base and can share what that was like or how you convinced that to happen, and did it end up better? I'm always kind of curious. Yeah.
I can try to talk about it. This is currently in progress, and that's very difficult to do because it's not just about refactoring a large code base. There is issue in the code base, in the CI/CD, in the build system, in the PC that we use, the laptop. There is issue too. So it's very difficult to make it happen, but it's our top priority. And so I feel the most important point is the human part, because how can I say that? Conduct this type of change in large team with a lot of people who work here for a lot of years, so they really like the code as what it is right now, but it needs to change. It really needs to change. It's difficult to make everyone go in the same direction, and it's because it's difficult to do it with other humans. It's difficult even when we have. It's even more difficult when we have very big technical issues. So we need to discuss. We need to find a tailor-made solution, very specific, very hard to find, but nobody wants to make the change, and it's a lot of things. And what I found useful to make it happen is that making small group of discussion for people who have the same idea, to make them, even if they are, how can I say that politely, they are not very focused on the issue, but they will share a little bit what are the pros and the cons about what we need to do. And with small meeting, with small team, and little by little making bigger meeting, we try to have a very good conversation about, so in this project we need to go in this direction. And we achieved to do that yesterday, I think. And we found out that the direction that our lead dev wanted is not possible. But some senior in the team didn't tell that for 2 months, I think.
Wow.
The team crashes were
to convince people to change, to fix this huge code bases when they tell you that, well, it's not our current business value and we should focus on providing the functional part. What arguments, what are the main things you tell them?
The first thing about that is that there was a big success in the company because the business, the top target of the business is changing the code base. I don't know how they did that, but they did that. So right now the issue is only in the dev side with engineer, because for the business we need to embed the run, obviously, but in 1 or 2 years we need to change all the code base to be able to scale maybe 10 times or 100 times, maybe more, because we are not sure what we can handle right now, but we are sure that we cannot maintain this code further. So we need a lot of discussion, and we need very smart people to. It's a bit of a shame, but we need it. We need smart people to think and try solution before we discuss about it, because people lost patience. So we cannot have all the discussion together. We need solution to confront the existent and other potential solution to start working in the right direction. That's very difficult, but it's working little by little.
Great. Yeah, thanks for sharing. I'll try to summarize that for the Discord people. I mean, in a sentence of, making huge architectural changes, eventually when they do have to be decided on, it sounds like they have to be championed sort of by small groups, technically showing that solution will work, that architecture change or that code change or whatever it is, so that something can scale. And the follow-on conversation of that is, how do you convince management? Because I think as engineers, we sort of know how to write better software, things that don't need to be as, less buggy software is good for the business, but getting that added business value on the sort of critical path is tough. Yeah, you want to add?
I think that one last thing on the part of convincing the managerial part is that we need metrics. Like when we do performance within our work, we need metrics. We cannot talk about perf without metrics. We cannot talk about refactoring without metrics. We need to tell them that if we do that, we can handle, I don't know, like right now, we can have two VM that run on the cloud on one computer. If we make this change, maybe we can have 4, maybe we can have 8, and so we can pay less. So it starts to begin interesting. What they want, why they want the change right now, it's really because they want to scale up a lot and they don't know how much, so they absolutely need us to make big change. But everywhere in the solution.
Awesome. Thanks for sharing. Yeah, so metrics, provide metrics. Just thinking about the other comment, which I don't know if we captured on Discord, about not being able to use Valgrind because there's spyware or something on it, like having some metric about I spend a lot of time using that and that'll save me days. I couldn't imagine not using that tool to find leaks. Yeah. So back up your what you need as an engineer. Yeah.
I think the ideal scenario, which is not always possible, is if you can apply big architectural changes incrementally. That's tough. Sometimes but if you can do that, it's much easier for several reasons. It decreases the risk.
Yeah.
It can be done in parallel with continuing to providing new value for the business. So it's not like you saying to the business, "Oh, we're stopping for 6 months. See you guys."
Right.
We can continue. We can have two groups of people working in parallel. One on improving the architecture. One on providing new features for the users who need them. But it's not always possible.
Yeah.
Something similar has been done, and now we're stuck maintaining 5 branches of the same software.
When I say incrementally, I don't say branches. For me, part of the incremental part is you can push partial changes to the master. Because if you start doing long-term branches for years, it's not going to be nice.
It will take 2 years. I had to migrate Windows code to Sans Salais. I was only 1 person and 20 person to make commit each day. I have to push my modification once a day. So I retake the modification, I recommit at the end of day. In the morning, I take it again, correct, push. 2 years to make it work.
I guess I have a follow-up. How many folks know who Titus Winters is in the C++ community? Titus Winters? Yeah, maybe a few folks. He's very active. Yeah. I think he's at Adobe now, but him and Hiram Wright, which have folks heard of Hiram's Law? Okay, another one of these laws, I know. But Hiram's Law is this idea of as your code base grows larger, inevitably some behavior, right, will be dependent on, whether it's buggy, or not. But the reason I bring up Titus and Hiram, they wrote this book about large-scale software engineering at Google. I think it's called Software Engineering at Google, actually. And it's freely available. So that could be another reference you can take a look at. But the interesting thing that this reminded me of is Titus always said in his talks was something they started doing when they write code in their log or assigned tasks, they ask themselves, how long is this code supposed to live? And I wonder if that would be an interesting nugget to put into your log of saying, okay, this code's only going to live 2 years, so it should be safe to refactor or throw away or have the incremental version. Just something simple. Maybe these are simple changes that can influence big things later. So.
Do you happen to know John Lakos?
Mm-hmm. Yeah.
Oh yeah. Okay. Well, I worked with him. At Bloomberg like a long time ago. I haven't seen him for actually ages.
Yeah.
But,
he's still around in the C++ community. Yeah.
Right. Oh yeah. I think he's still at Bloomberg.
And still at Bloomberg. Yep.
That's right.
Yeah.
Because I was there. I don't know if he ever told you about. I guess he was told or tasked at Bloomberg when he first got there that he's got to sell. They brought him in to restructure things. I think deliberately because he'd written the book. It was a large scale C++ design, whatever.
Yes. Yep. Yeah.
So he took as a prop around all the groups, mainly the management groups, a ball about this big of rusted wire, and he said, "This is your code base." Right? Anyway, now, that was, I think it was effective, but it did cause some irritation. Right? But also, he had a very, he's built BDE, right? Which is the underpinnings of C++ at Bloomberg, and it's really good. And I know a lot of parts of it which are really good, but it's a bit unusual in compared with a lot of the design of things which was going on at the time. And there were some people there at Bloomberg who were quite senior engineers. They put together sort of petitions and big meetings and everything like that. But anyway, so John came through, and what we have now is a testament to his persistence and good engineering, really great engineering. So it was a very interesting. It was an example of successful, really total re-engineering, and there's not that many.
Yep.
So that was I wasn't only there for the beginning of it because it was over probably 15 years. So,
Yeah, that's a great example. I mean, for those of you who don't know, you should watch some of John's talks, and he's written a second book, second edition of this large C++ scale.
Yeah, I think there's probably going to be 5 books. But there needs to be. And it's things like files should be around about 1,000 lines, right? Whatever they are.
Yeah.
You shouldn't get much bigger than that.
Yeah, he's got a bunch of those. I mean, this came up earlier about the file structure, like the physical and the logical structure of your project, which is one of the things I remember from him.
Yeah.
So whatever these, come up with some guidelines, rules that help your architecture, right? Yeah. So, Other thoughts for the group? Anyway, this has been great. Yeah. So, all right. Well, thank you. Yeah.